A graph of position versus time for a certain particle moving along the x-axis is shown in figure. Find the average velocity in the time intervals from letter A, 0 to 2 seconds, letter B, 0 to 4 seconds, letter C, 2 to 4 seconds, letter D, 4 to 7 seconds, and letter E, 0 to 8 seconds. Below the problem, here is the graph showing the distance traveled for a specific time. Now, to solve this problem, maybe we can create a table that is equivalent to the graph of the problem. Okay, now creating the table, let's say this is the time and this is the time and this is the distance traveled, which is, let's say, x. Then initially the distance traveled is 0. After 1 second we have 4. After 2 seconds it's the maximum. Then after 3 seconds we have 7. After 4 seconds we have 5. 5 seconds is the speed is constant, 5. 6 seconds we have 0. 7 is negative 4. 8, that is 0. Now, to solve for letter A, getting the average velocity, we know the average velocity, that is the displacement over time. Then if A is equal to the displacement after 2 seconds is from the table, that is equal to 10. How about at t is equal to 0? We have 0, and for the time we have 2 minus 0. Then getting the average velocity, we have 10 over 2, which is also equal to 5.00 meter per second. That is our answer for letter A. How about letter B? For letter B, we're getting the average velocity from 0 to 4 displacement after 4 seconds, that is equal to 5 minus 0 all over. For time we have 4 minus 0. Then simplify that one, we have 5 over 4, or 5 over 4 is also equal to 1.25 meters per second. Letter C. Solving for the average velocity from 2 to 4, displacement after 4 seconds is 5 minus, for 2 seconds, that is 10 all over 4 minus 2. Simplify the equation with negative 5 all over 2, which is also equal to negative what? What is negative 5 over 2? Negative 2.5. 0.50 meters per second. For letter D, solution here, average velocity after 7 seconds is, looking back to the sketch, that is, I'm sorry, instead of negative 4 it should be negative 5. Therefore this is negative 5 minus 5 all over 7 minus 3, or 7 minus 4, Therefore, this is also equal to negative 10 over 3, or 3.33 meters per second. How about letter E? For letter E, the average velocity from 0 to 8 after 8 seconds, that is equal to 0 minus 0 over 8 minus 0, or that is also equal to 0 over 8, or final answer 0. That is our final answer for letter A. And these are our answers. Okay. A tennis player moves in a straight line path as shown in figure. Find her average velocity in the time intervals from 0 to 1 second for letter A, for letter B, 0 to 4 seconds, for letter C, 1 to 5 seconds, and letter D, 0 to 5 seconds. Again, our solution here is, let's try to create a graph again, or a table that is equivalent to this graph. Let's say again, this is our time, and the other side we have the distance traveled. At t is equal to 0, the distance traveled is initially 0, then 1 is 4, 2 is 0, 3 is negative 2, 4 is negative 2, and 5 is 0. Okay, our solution here for letter A, finding again the average velocity. We know that the average velocity is the displacement over the change in time, which is equal to what? For letter A, that is 0 to 1 seconds. After 1 second, this one is equal to 4 minus 0 all over 4 time, that is 1 minus 0. Therefore, our answer here for number 1 is 4.0. Unit for the velocity is meter per second. That is for letter A. For letter B, again, the average velocity is equal to, looking back to the table, 4 seconds is negative 2 minus 0 over 4 seconds and 0, or this is also equal to negative 2 over 4. Negative 2 over 4 is negative 1/2, or negative 0.50 meters per second, meter per second. For letter C, solution for letter C, getting again the average velocity from 1 to 5. The distance after 5 seconds are 0, and for 1, that is 4. 5 minus 1, or this is also equal to negative 4 over 4. Negative 4 over 4. Our final answer here is negative 1.0 meters per, or meter per second. For letter D, velocity, average velocity from 0 to 5. 5 is 0. Initial time, 0 over 5 minus 0, where this is equal to 0 or 5, or answer for letter C is 0. That is our answer. And these are our answers. The velocity versus time graph of an object moving along a straight path is shown in figure. Find the average acceleration of the object during the intervals A 0 to 5 seconds, B 5 to 15 seconds, C 0 to 20 seconds. And for the second set of question, find the instantaneous acceleration at A 2 seconds, letter B 10 seconds, and letter C 18 seconds. Again, solution here, let's try to create a table that is equivalent to the graph. But here, before, we are using time and the displacement or the distance traveled. Here we will be using the graph for time and velocity. Okay, I'm doing the table. Let's say this is again the time, and this is the velocity. Let's say the time is every 5 seconds. Let's say 0, 5, 10, 15, and 20. At 0, the velocity is negative 8, 5 is still negative 8. We have a constant velocity here, and the velocity is increasing. We have constant acceleration here. We have 10 is 0 and continuously increasing. We have here 15 seconds is 8, and after 20 seconds constant velocity, acceleration is equal to 0. Okay, 20. Now for the first question, we are looking for the average acceleration, and getting the acceleration, that is the change in the velocity with respect to the change in time. Therefore, we have at t is equal to 5 seconds, the velocity is equal to negative 8 minus t is equal to 0. We have minus of negative 8 all over. We have 5 minus 0. We have here negative 8 plus 8 over 5. Negative 8 plus 8 is equal to 0 over 5. Our answer is 0. For letter B question, we are looking for the acceleration from 5 to 15. For 15 seconds, that is equal to 8, and for 5 seconds, that is equal to negative 8. Here we have 15 minus 5, that is equal to 8 plus 8 over 10. 8 plus 8, that is equal to 16 over 10. Therefore, answer for letter B is 1.6 meter per second squared. That is for letter B. For letter C, acceleration is equal to from 0 to 20. Therefore, for 20 seconds, that is 8. 0 is negative 8 over 20 minus 0. Or we have here, this is also equal to 8 plus 8 over 20, which is equal to 16 over 20 is 0. That is 0.80 meter per second squared. Now for the second set of question, here the unknown is the instantaneous acceleration. For the instantaneous acceleration, meaning that is the acceleration for that given time. Now here we can say that this line, or the slope of this line, will will describe the acceleration of the given graph, meaning getting the slope of this part of the line is equal to what? The slope of the line, let's say the slope of the line is equal to the acceleration of the line. Then to get the instantaneous acceleration for letter A, that is the instantaneous acceleration after 2 seconds. Short, we are getting, that is for the line, for the slope, let's say this is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Then getting for the instantaneous acceleration after 2 seconds, that is y sub 2. Let's say this is for y sub 2 is the height for 2 seconds. Where is 2 seconds? Somewhere here at the middle. That is equal to what? What is the slope of the line after 2 seconds? Meaning this line describes that question. For letter A, that is what is y sub 2? Getting any point here, y sub 2 is negative, let's say negative 8 minus of negative 8 all over, say, getting any value from that x sub 2, that is from, let's say, x sub 2 minus 0. And here we have negative 8 plus 8 all over 2. Negative 8 plus 8 is equal to 0 over 2. So this one is equal to 0. As you can see from this part of the equation, from this part of the line, the slope of a horizontal line, is equal to 0. The slope of a horizontal line is equal to 0. Okay, for letter B. For letter B is for 10 seconds. For 10 seconds, 10 seconds is somewhere here. And here, we need to find the slope of this line. Because the slope of this line from any point here is also equal to the slope of 10. We will be using 5 and 15 value. Okay, you can choose any point here, but I will be choosing 5 and 15. Okay, therefore the answer for letter B for 10 seconds, let's say for 15, y sub 2 is 8, and for 5, y sub 1 is negative 8. And here I will be using 15 minus 5. We have 8 plus 8 all over 15 minus 5 is 10, or this is 16 over 10, or it's also equal to 1.6 meter per second squared. Again, for letter C. For letter C, getting the acceleration for 18 seconds located somewhere here, the middle. Again, you are looking for acceleration from this part of the line. And as you can see, there is what? A horizontal line again. Meaning, the slope for the horizontal line, or for that horizontal line, let's say I will be using 15 and 20. So you can see our answer here is 0. But let's try using this formula, the slope. For the slope, that is, let's say 8 minus 8 for 15. And this one is, let's say 20 minus 15. Therefore, we have 8 minus 8. As you can see, that is equal to what? 0. We have 5. This is 0 over 5. That's also equal to 0. That is our answer. Because as you can see, from this part of the line, this one is a horizontal line. And again, the slope of a horizontal line is equal to 0. And for our answers, here are our answers. Okay. A particle starts from rest and accelerates as shown in figure. Determine, letter A, the particle's speed at t is equal to 10 seconds and at t is equal to 20 seconds. And letter B, the distance traveled in the first 20 seconds. Now, for the given figure, here we have time and acceleration. And to solve for the speed, we know that acceleration A, or acceleration, is the velocity over time, or the speed over time. Then, to get the unknown speed, say V, is equal to what? A times the given time t. Now, for this sketch or graph, we can create another graph that is time in terms of its velocity. Now, let's try this graph, which is equivalent to that graph for let's say this is our velocity, the y-axis is our velocity, and the x-axis is our time. Terms of seconds, and the velocity is in terms of meter per seconds. Okay, now from the figure above, we can see here that the velocity, the acceleration, is constant. Since the acceleration is constant, the particle's speed is constantly increasing. Say from 5 to 10 seconds, the particle's speed is constantly increasing. In short, we have initially from 0, it increases up to some point, say where is there? Okay, we're in the max value here, since this one is velocity. The velocity after 10 seconds, is equal to the acceleration, which is equal to 2 times the time, which is equal to t. Therefore, this one is 20 meters per second. Therefore, the height here, the level here is 20. Okay, now from 10 to 15 seconds, so you can see from 10 to 15 seconds, the velocity, the acceleration here drops, and this one, from it drops, then again it became constant. Okay, therefore, since it drops then became constant, therefore this one is from 10 to 15 seconds. Okay, this one is 15 seconds, and for 15 to 20 seconds, so we can see here the acceleration is negative, meaning since the acceleration is negative, this one is decelerating. If the particle's acceleration is decelerating, meaning to say its speed is what? Decreasing constantly. Therefore, the result is this one is decreasing up to a certain point. Okay, up to a certain point. Okay, since the length of this one is 5, since the length of this one from 20 minus 15 is equal to 5 seconds, therefore the velocity for that 5 seconds for 5 seconds, and the acceleration is negative 3 times 5, which is 5 seconds, that is equal to negative 15. Therefore, we go downward, the level here is, it goes downward by 15. If this one is 20, meaning the height here from this point up to 20, from this point, this one is equal to 5. Okay, it drops by 15 for the value of y. Now, for letter A, solving for letter A, the particle's speed after 10 seconds, let's say the speed at 10 seconds, looking from the figure that we have done, the speed after 10 seconds is located at this point. Therefore, the particle's speed after 10 seconds is equal to what? Acceleration F2 times 10 seconds is equal to 20 meters per second. That is for letter A at 10 seconds. And at T, at 20 seconds, looking our figure again, from our reference point, 0 reference here, the velocity after 20 seconds, since it drops by 15 seconds, meaning our velocity here is from this point up to this point, which is equal to 5 seconds. Therefore, the velocity here is equal to 5 seconds. How about letter B? Solving for the distance traveled. And for the distance traveled, in the first 20 seconds, to solve that one is we need to get the distance traveled from 0 to 10, 10 to 15, and 15 to 20. And to solve that one, we will use the kinematic equation. What kinematic equation that are we going to use? We have this. We'll be using the kinematic equation. That is x is equal to the initial velocity times the time plus 1/2 the acceleration times the square of the time. Then getting for the first 10 seconds, this one is from 0 to 10. From 0 to 10, what is the initial velocity? The initial velocity here is equal to 0. Yeah. So you can see from here the initial velocity from 0 to 10, and let's say our t here is equal to 10 seconds, and the acceleration is equal to what? Constantly increasing velocity or speed. Therefore, acceleration here is 2 meter per second squared. Okay, then substituting the value, we have x is equal to the initial velocity 0 t plus 1/2 times 2 times 10 square. Therefore, x here is equal to 1/2 times 2 times 10 squared. Cancel. We have 100 meters. That is from 0 to 10. Next is from 10 to 15. From 10 to 15, as we can see here, the acceleration is equal to 0 from 10 to 15 seconds. And next, the velocity here, let's say what are we going to use? The initial velocity. Okay, let's say the initial velocity here from this point, from 10 to 15, is equal to 20 meter per second. And how about the time? For the time, that is 15 minus 10. Therefore, this is 5 seconds. Therefore, we can use this formula again. X is equal to 20 times 5 plus 1/2. The acceleration is equal to 0 times 5 squared. This one will cancel out. Therefore, x here, 20 times 5 is equal to 100 meters. And next one is from, let's write it here, from 15 to 20. From 15 to 20, as you can see, the velocity here at this point, let's say you'll be using the final velocity from this point is equal to 5 meter per second. Let's say the acceleration from that is negative 3 meters per second squared, and the time is equal to 20 minus 15 is also equal to 5 seconds. Okay, and then from here, since we'll be using the final velocity, our kinematic equation here, the kinematic equation that we'll be using here is let's see, Vf squared is equal to the initial velocity squared plus 2a times x. We need the value of x here, and again we do not have the value of the initial velocity. Looking back again here, the initial velocity from 15 to 20, the initial velocity here, let me write it, the initial velocity is equal to 20 meters per second. Therefore, by substituting or by manipulating the formula, we can get x is equal to the f squared minus the initial velocity squared all over 2 times the acceleration. Therefore, x is equal to what? It's the final velocity again is 5 squared the initial velocity, 20 squared all over 2 times negative 3. Getting the value of x is equal to 62.5 meters. Therefore, the total distance traveled, let's say x total, is equal to 100 plus 100 plus 62.5. The total distance traveled is 262.5. But based from here, we have 3 significant figures. Therefore, our x total here is 263 meters. That is our final answer. Okay, therefore these are our answers. Okay. You drop a ball from a window on an upper floor of a building and it is caught by a friend on the ground when the ball is moving with speed Vf. You now repeat the drop, but you have a friend on the street below throw another ball upward at speed Vf exactly at the same time that you drop your ball from the window. The two balls are initially separated by 28.7 meters. Question, letter A, at what time do they pass each other? And letter B, at what location do they pass each other relative to the window? Okay, for this problem, let's try to sketch again what is or what happened to this problem. Assuming this is your house or have a building here. Say this is a building. Then let's say there's a window here where your brother, or what did I say, brother, or that person throw that stone downward. Say the motion of stone is going downward, and there's a man below the building who catches that stone and throws it upward too. Okay, throw it upward too. Then the motion of the second stone is, say, going upward. Okay, and the height where that man threw the stone is given by 28.7 meter. Now here, to solve this problem, to solve for letter A, which is at what time do they pass each other, meaning at what time or at a certain point here where this man throw the stone downward, and then this second person throw the stone upward. At certain point they meet each other. The two stones meet each other. Let's say at this point they meet each other, but we do not know the time where they meet each other. Now for our given here, let's evaluate our given here. We know that the height, let's say y, is equal to 28.7 meter, and at the instant you throw this person throw the stone downward, the initial velocity of the stone upward is equal to 0. Let's say upward, the initial velocity at this point is equal to 0. Now reaching the stone downward, it reaches a certain velocity wherein we do not know the velocity, and this velocity will be the initial velocity when this person threw the stone upward. Therefore, getting the final velocity, we know the acceleration is due to gravity, and since the motion is downward, we'll be using 9.81. And to solve this problem, we will use the kinematic equation. The kinematic equation for letter A. We're using the kinematic equation. Solving for Vf, we have Vf squared is equal to the initial velocity squared plus 2gy. Okay, then substituting the given value, solving for the final velocity, this one is equal to 0 squared plus 2 times the gravity, acceleration due to gravity, and the height is 28.7. And to solve for the value of Vf, squaring both sides of the equation, we can get the final velocity when the stone reaches the ground is equal to 23.73 meters per second, wherein this final velocity is the initial velocity when the object is thrown upward. When the object is thrown, or the ball is thrown upward. And also this one is the final velocity when the stone is thrown downward, when it reaches the bottom, when the ball, I'm always saying stone, when the ball reaches the bottom of the building, reaches the bottom. Okay, then here we have the initial velocity. We have here the initial velocity when it is being thrown upward, and here we have the final velocity of this stone, of the first ball, when it is drawn downward. Now to get the time, we will be using this equation. When the ball is thrown downward, there is a certain height where they meet each other, or where their height is equal. Meaning, we'll be using this equation when the stone is traveling downward, the stone is also traveling upward. The equations that are we going to use here, let's say again, the kinematic equations we have y is equal to the initial velocity times the time plus and minus 1/2 gravity times the time squared. We'll be using positive if that is downward, and we'll be using negative if the ball is traveling upward. Okay, then since we have the initial velocity for both objects, we can use this equation from the two. For y downward, which is positive, I have the VOT, the initial velocity during downward is what? 0 times its time is we do not know, plus 1/2 the gravity. We know the gravity is 9.81, and the time still we do not know. You will equate that one when the stone, the ball is traveling upward. With the initial velocity 23.3 or 23.73 t minus 1/2 times 9.81 times t squared. Okay, then let's simplify this one. We have 1/2 9.81 t squared, then we have 23.73 t and 1/2 9.81. If this one will be transposed to the left side, therefore we have 1/2 9.81 t squared, negative will become positive, plus 1/2 9.81 t squared is equal to 23.73 t. 1/2 times 1/2, therefore it will become 9.81 t squared is equal to 23.73 t. And if you divide this both by t, this will cancel out and one of this will cancel out. Therefore here we have 9.81 t is equal to 23.73. Then t is equal to 23.73. Divide this one by 9.81. Therefore t is equal to 1.21 seconds. Okay, that is for the letter A. How about for letter B? For letter B, we will only use one equation, either downward or upward. Let's say again we have y is equal to VOT. Let's try the downward motion, 1/2 GT squared. Therefore, getting the y, or the point where their height is equal, have y is the initial velocity during downward, so 0 times 1.21 plus 1/2 the gravity 1.81 times the time is 1.21 squared. Then the value of y is the value of y, this one will be equal to 0. Then our height is 7.18 meters. Okay, those are our answers.